Hello, welcome to your channel Simple Math for You, and our lesson today will be about graphing inequalities into variables. أهلا بكم في قناتكم Simple Math for You، ودرسنا اليوم هو رسم المتباينات التي تحتوي على متغيرين. Let's learn how to graph linear inequalities into variables. The graph of linear inequality represents the set of all points that are solution of the inequality. We are looking for a solution. Now, in the inequality, we are going to follow the same procedure that we followed before to graph a line. So in the inequality, we will graph the boundary line. So we will have, this is the coordinate plane, we will have boundary line, some boundary line like this. And this boundary line can be solid or can be dashed or dotted. And it will divide the coordinate plane into regions called half planes. So this cuts the coordinate plane into half planes. When the boundary is included, the solution is closed half plane like this. When it is not included, when it is dashed, we can say, it is called open half plane. In this way, let's change the color. It is open half plane. So what are the steps that we are going to follow to graph linear inequalities? First, we will graph the boundary line. We will use solid boundary when the inequality has equal sign. And we will use dash boundary when it does not have the equal sign. Then we will use test point to determine which region we are going to shade, above that line or below that line. And then we are going to use the test point, and then after testing point, we will shade to indicate the region, the required region. Let's take examples to make it easier. Graph each inequality. Number one, y less than x minus 3. The boundary line here is y equals x minus 3. How can we graph y equals x minus 3? To graph a line, عشان نرسم خط لازم يكون على الأقل عندنا نقطتين. We have to have minimum 2 points. Since y is isolated, it is this written in slope-intercept form, so we can generate a table. We can assume any value of x and solve for y. And we like to assume x0 and x1. If x is 0, then y is 0 minus 3, which is minus 3. When x is 1, so y is y minus 3, which is minus 2. So now we have 2 points, 0 and minus 3, 1 and minus 2, 1 and minus 2. This is minus 2, this is minus 3. Now, before we decide to match, let's check the inequality. Does it have equal sign? No, it does not have equal sign. So our line will be dashed. We will match with dashed line. And then the third part, so this is dashed, because it's less than only, there is no equal sign. And then to decide which region we are going to shade, above the line or below the line, let's take a test point. The test point should not be on the boundary line itself. So let's choose any test point above the line, let's say. If you take this point, what is the coordinate of this point? This point is 1 and 0. 1 and 0. Let's replace here 1 and 0 and check whether it gives us the correct inequality or not. So y is 0 less than x, I replace it with 1, 1 minus 3, so 0 less than minus 2. Is 0 less than minus 2? Of course, this is wrong. Since this test point gives us a wrong inequality, so we are not going to shade the region including this point. مش هنضلل المنطقة اللي تحتوي على هالبوينت طالما أعطتنا غلط. So we will shade the other side. So this is the solution of the inequality that we are looking for. Of course, we shouldn't exceed the line. Okay. This is about graphing in general. Okay, can we ignore the part of test point? Yes, by experience, if you have y less than, and the x is this side, so you will shade below the line. Remember, it's y, not negative y. If it's negative y, then it will be y more than if you divide by -1. So be careful. And by experience, you will know that it's always true. Let's see this one. Again, we will first graph the boundary line. This is the table. Assume x, this is x, this is y. When x is 0, 3 times 0, 0 minus 1 minus 1. When x is 1, 3 times 1, 3 minus 1, 2. So we have 2 points, 0 and minus 1, 1 and 2. This is 1 and 2. This is 1 and this is 1. And since we have greater than or equal, that means it's a solid line passing through these 2 points. Solid line. متصل. مش منقط, مش مقطع. And by experience, as I told you, since y is more than, then we should expect that we are shading above the line. Let's check. Let's take a point anywhere above the line, and it should give us the correct inequality. So if you take test point, let's take somewhere above the line. Let's take any point. Let's say this point. This is 0 and 4. And let's replace y more than or equal 3x minus 1. So 4 more than or equal to 3 times 0 minus 1. Is 4 more than minus 1? Yes, it is. So yes, correct. So we will shade the region, including this test point, since it gives us the correct one. So we have here revised how to graph using a table. Let's see this one. Question number 3, 6x plus 3y greater than 12. For this example, I would like to use x-intercept, y-intercept method. However, I can simplify before. I can divide everything by 3. So it will be 2x plus y more than 4. It's easier to simplify. And now I can assume to find x-intercept, y-intercept, if you remember. You can also convert this to the other side and graph the line. For example, we have here 2x plus y equals to 4. You can say y equals negative 2x plus 4. You can graph this one, but I like to revise the method of x-intercept, y-intercept method. So to find x-intercept, assume y 0. Then 2x is 4 because this y will be 0. And x is divide by 2, x is 2. So when y 0, x 2. Now let's assume x 0. To find y-intercept, assume x is 0. So we have 2x plus y is 4. Now x is 0, so y is 4. So our points are ready. 2 and 0, it's on the x-axis. And the other one, 0 and 4 on the y-axis. And now when you match, be careful, it is a dashed line, dotted line, because it has greater than only. And as I told you by experience, you should know that now if you shift the 6x to that side, it will be 3y more than negative 6x plus 12 divide by 3, divide by 3, divide by 3. The most important thing that at the end you will have y more than. So you will know that you should shade above the line. But let's assume test point for double checking. خلينا نشوف test point. So test point should not be on the line itself. Take, let's say this one. It's a good, nice one, 0, 0. We should expect that it's not included in the shaded region. نتوقع إنها مش معانا في shaded region. Let's just replace. So if you replace here 6 by 0 plus 3 times 0 more than 12, 0 more than 12, is that correct? No. So that means the shaded area should not include 0, 0, which we expect. So this is enough. Let's do this one. So the boundary line is 5x plus y equals to 10. We can write it in slope intercept form so that it's easier for us to generate our table. So if x 0, then y equals to 10. If x is 2, y is negative 5 times 2 plus 10. Negative 10 plus 10 is 0. And we can rechange the scale. We can rescale it. We can say 2, 4, 6, 8, 10. And this is as well 2, 4, 6, 8, 10. 2, 0 is this one. 0, 10 is this one. And we will match using a dashed line. And then, of course, you need to use your ruler. And then you will shade. I expect that the shading is above the line. Take any test point. Test point. I'm taking 0, 0. 5 times 0 plus 0 more than 10. So 0 more than 10, no. So really 0, 0 is not included in shaded area, which is correct. Bravo. Now for this exercise, same thing. I try to simplify. I can write it in a better way. And I can generate my table. When x is 0, 0 plus 7, 7. When x is 1, minus 5 plus 7, which is 2. So we have 0, 7. One, 2. And now our line is solid line. Solid. Since y is less than, so I should expect shading below. Let's take a test point, which is 0, 0. Replace 10 times 0 plus 2 times 0 less than or equal to 14. 0 less than or equal to 14, correct? Yes, so 0, 0, the point that I have chosen and gives me gave me a correct inequality. That means it should be included in the shaded area. Yes. إذا بناخد نقطة ونتحقق منها. إذا أعطتنا جواب صحيح معناها الشيدنج التضليل يتضمنها. إذا لم معناها نضلل الجهة الأخرى من الخط. Now we have one variable only. And let's see how are we going to use it. So 2y more than or equal to minus 6. I can divide, simplify as much as you can. So what is the boundary line here? The boundary line is y equals to minus 3. Y equals to minus 3 is a horizontal line passing through the minus 3. So at minus 3, we will graph a horizontal line. Shall it be solid or dashed? It will be solid because there is greater than or equal. So it will be horizontal line passing through the minus 3. And now, since y more than or equal to minus 3, that means my shading should be above the line. You can check with any test point. Let's check. Let's test with any point above. Any point, we can take it. We can take this one, which is 0, 2. So if 0, 2, you are not going anyway to use the x, you are just going to use the y. So is 2 more than or equal to minus 3? Yes, of course. So we were right. Now we have here another inequality with one variable only, and this time it's x. As usual, we are going to isolate the variable. كالعادة راح نعزل الفاريبل ونحل للx less than 3 minus 1. So half x less than 2, multiply both sides by 2 to get rid of this fraction. So this cancel and x less than 4. So my boundary line will be x equals to 4. X equals to 4 is a vertical line passing through 4, but this vertical line will not be solid as I have done here. It should be dotted or dashed. Now, x less than 4, definitely less than 4 will be to the left. When x is less than the 4, it will be to the left of the 4, of course. So this is the inequality that we are looking for. Let's apply here according to what we understood in real life application. In 2006, the median yearly family income was about $48,000 per year. Suppose the average annual rate since then is $1,240 per year. So this one is changing per year. Write and graph an inequality for the annual family incomes Y that are less than the median for X years after 2006. So what shall we do? We will assume that the average annual rate, which is Y, he said that it's Y, the income is Y, should be less than 1,240x, where x is the number of years, plus the fixed one, which has been written before, that one, which is the income before. The income before, yes. And you are asked then to graph it. So as you see here, we are only using the first quadrant since we don't have any negative numbers of years. Here, our label will be years since 2006. And here, it will be our income in dollars. So we will change the scale since we are not going to use everything here. So we will start by the 44,000 and then 46,000, 48,000. Actually, 2 points will be enough for us. Let's generate our table to see where can we reach. If x is 0, then definitely the y, which is the income, will be 48,200. So we will start here. Then when x is 1 and you replace x by 1 to 40 times 1 plus 48,200, it will be 50,680. And if you continue labeling here, this will be 50,000 and this will be 52,000. So it will be somewhere here, 50 something here. Somehow here. When year, this is year 1, this is year 0, sorry. This is year 1. So year 1 will be paired with 50 point something somewhere here. Very near. And before I match, I should notice that there is no equal sign here. So I will use dotted line. This is the graph that I'm looking for. Now, where is the shading? Since y is less than, you can also use this point, but we know that it's less than, so we should shade below the line. And below the line means only surrounded by this area, because this is what I have here in the real life application. So this is the shaded region that I'm looking for. Now, in part B, determine whether each of the following points is part of the solution set. How can we do that? We can use two ways, either algebraically or using the graph. How can we use that? If you want to use the graph, then check this point. Where is this point? 2 and 51,000. So you go to 2 and 51,000. 2 and 51,000, where does it locate? Is it located on the boundary line, below the line, or above the line? So as you see here, if you look carefully, 2 and 51, it will be somewhere above the line. Actually, if my line is good, it's not that good. No, 2 here, 2 and 50 something. If it is below the line, then if my graph is okay, then if it is in the shaded region, then it's part of the solution. If not, then it's not. So to be in the safe side, if you are not sure about your shaded area, then you can simply replace. So take the y and replace it with 51,000. Take the x and replace it with the value 2. And check the inequality resulting. Let's check. This is this side 51,000. And for this, 2 times 1240, which is 2,480 plus 48,200, it will be 5680. So, is this okay? Is this okay? Yes. If it is giving us okay, yes, in the shaded region, then it's in the solution. Is 51,000 less than 50,000? Of course not. So this is not part of the solution. You will repeat this procedure for every point here. You will check for this point. You will find that it is not part of the solution. It's above the shaded region. You check the third one. You will see that, yes, it is a part of the solution. It gives you the right inequality. For this one, it's not a part of the solution. You can take it as a task and solve it, and it is easy. You have two options. If your graph, you are sure that your graph is accurate, then check. If it is below the line, means in the shaded region, then yes, it's a part of the solution. If not, then if you are not sure, then you can substitute as I have. Last question here is analysis to find the error. We have two guys are solving, and they are solving by graphing. Is either of them correct? Let's check. For this guy, he divided by 4 to simplify. He did the right job here. And when he graphed the line, we have a solid line. Yes, of course. Yes, because there's an equal sign. When he took a test point 1, 1, he gives him a false point for 1, 1. We can check 1 is less than or equal to 2/3. So false. Since this is false, then he shaded the other way around. So absolutely, Rico is correct. For this guy, or for this Christine lady, I mean, she has done the correct graph, solid line, yes, passing through 0, 0, the line is correct, but let's check the shaded region. She took 0, 0 as a test point. We said that you cannot take a point on the boundary line itself. You will not be able to identify the shading will be above or below. ما تاخد point على الحدود نفسها على الخط. خد point يا أعلى يا أسفل، يا إما فوق الخط يا إما تحت الخط. فلما تجرب هذا أصلا غلط، تجربته غلط. So here تجربة 1-1، يعني خد واحد فوق واحد here or you can take here as well. Let's for example assume here you have here 1 and or here مثلا هذا ناخد واحد سهل 1 and minus 3. 1 and minus 3 is a good point. Why? Because we have a fraction here. So let's replace this minus 3 less than 2/3 times 1. Is minus 3 less than or equal to 2/3? Of course, yes. So the shaded area should include this point. You can choose any point. You have infinite number of test points. So summary, this is correct and this is wrong because you can't choose a test point on the boundary line. So as a summary of this lesson, the graphing inequality, we need to learn that we are graphing the boundary line first, which is normal line linear equation using the table or using the, you can use also the slope intercept form, by the way, or you can use the x-intercept, y-intercept method. Number 2, decide whether you are going to draw solid line or dash line, يا منقط يا إما متصل. ثالثا، لتحديد المنطقة المضللة, to identify the shaded region, take a test point. Use any test point. If it gives you the correct answer, then shade that region including this point. If not, then shade the other region. And this will be how to graph any inequality with two variables. If it is one variable, then it's either a horizontal line or vertical line. So the shading will be above or below if it is horizontal line, will be to the right or to the left if it is vertical line. And we applied the real life application. And with that, we are done with this lesson. Thank you all and goodbye.